All right, welcome back. Our first talk this afternoon is Dan Garfield. He's going to tell us about visualizing Canary Rollouts with Istio and Helm. Please welcome.
Thank you. Everybody has been properly fed and is now lulling into a nice restful state, so I'll try not to disturb that too much with my loud motions, rapid movements. But excited to be here. Just flew in last night and flying out this afternoon. It's my first time in Detroit. I stayed in a haunted hotel, which is a whole thing. So if you want to hear about that, talk to me later. But to introduce myself, my name is Dan Garfield. I'm the Chief Technology Evangelist for a company called CodeFresh. We're a cloud-native CI/CD platform designed specifically for working with things like Kubernetes, serverless, those kinds of things. And Canary is something that we've worked quite a bit on and have been doing for a while. I'm a Google Cloud developer expert focused on Kubernetes and cloud and DevOps applications, and then I'm also a member of the Forbes Technology Council. So those are my bona fides. You can follow me on Twitter at @todaywasawesome. If you get nothing else from this talk except that you follow me on Twitter, that'd just be fabulous with me. So thank you for that. That's your cue to laugh. Thank you. All right. So first off, we're going to talk a little bit about the Kubernetes stuff. For those that haven't used Istio before, my way of explaining what Istio is that if Kubernetes is your game that you want to play, Istio is your game genie. It's like this crazy, overpowered, amazing tool set, Swiss Army knife that lets you do a million different things in a super powerful way. Anybody using Istio today or a service mesh? I see several Istio contributors in the audience who are using it, which is excellent. Everybody using, what about Kubernetes usage? Get a feel for the room. Like 50%? Okay, all right. How many people are doing canaries already? Whew, all right, excellent. So, for the two of you that already do it, we'll see how useful this is. So the basic idea of a canary is this. You deploy a new version of your application. You give some portion of traffic to that new version, and if it works, you ramp up and get to 100%. So you start with the production version of your application. All of your users are getting that production version of the application, and then you roll out the new one, and then you start to shave off that little bit of traffic and send some of those people over to the new version of the application. And if everything looks good, you continue to increase it until you reach 100%. And then you can remove the old version or keep it around as a hot swap in case there are future issues. This is a pretty critical tool to have in your deployment, especially in mission-critical applications, because it enables you to do much more reliability in your deployments. Now, a lot of people, when I talk to them about Canary, they think that it's all about testing the impact of changes. Like, oh, I can roll out a new version of my application. They'll get a new version of the shopping cart. That'll only get exposed to 10% of my traffic, and everything looks good. It'll get rolled out. That is the wrong use for Canary. We invented something for that a long time ago. It's called feature flags. It's fantastic at that job. That's actually not the job of Canary. The job of Canary is really to limit damage from regressions. So if you roll out a change that has some sort of cascading problematic effect, that's why you do it. So a good example of this is, not to pick on anybody, I always am afraid that I'll mention names and like someone will be in the audience and they'll sink down because they were part of that. But Cloudflare recently had a global outage. Now, why did that global outage happen? It was a simple configuration change that was rolled out 100% globally all at once, which caused their entire platform to fail. Now, if they had actually been using Canary releases on that, they would have detected it in a very small region, very small percentage of their users immediately, and prevented the change from going forward. So that's an instance where, I mean, that's something that cost them hundreds of thousands of dollars because of that outage. Similarly, AWS had an outage about a year and a half ago that was also from a configuration change that should have gone through a CI/CD system and should have also been canaried, because if it had, it would have caught that there was a runaway train effect going on, and it would have stopped it and rolled it back to the previous state. So canaries are pretty critical. Their purpose is not to test the impact of changes, it's to limit the damage. So this actually comes hand in hand with the adoption of microservices. How many people are microservice oriented today? Okay, how many people think they should be? How many people can raise their hand? Because I'm just trying to see if maybe it's just the after lunch lull. They're like, microservices, it's kind of bullshit, not into it. Seems like most people are into it, but I think I just found the floor for how many people can raise their hands. So anyway, when you have a complex infrastructure, the usefulness of testing early actually gets much more difficult. When you've got a monolithic application that you can stand up in Minikube, and Minikube, I mean, if you think about it, if you can stand up your application in Minikube, Minikube is the worst version of the cloud, right? It's a single node that's underpowered, doesn't have enough RAM, and has a bunch of crap running on it also. It's like living in a shared VPC from the 90s. I mean, it's just the worst possible situation you could be in. So testing an application that has 150 different microservices, well, gosh, you're not even going to be able to do that locally, first of all. And second of all, even if you do stand up a lot of that infrastructure within your CI/CD systems and maybe do staging and things like that, you still have situations where maybe you have components that can't be replicated. Maybe you're integrated with third-party providers. You've got a Salesforce instance that you don't have a way to just spin up and shut down instances willy-nilly for every commit and change. So I'm a big advocate for early testing everything as much as possible. I want security scans every commit. I want to do unit testing on every commit. I want to have all that stuff in front of me so that I can fix it well before I go to make a pull request. It's one of the worst patterns in the world is that we test after pull request, because that means you just took the most expensive resource, which is one of your senior engineers, to go and do a code review on code that wasn't even tested. I mean, it's not a great pattern. So the usefulness of that early testing, it really goes down as the infrastructure becomes more complex because the interactions are more complex, right? You know as well as I do that as you add microservices, you increase the number of interactions and touch points exponentially. So every microservice you add becomes that much more complex to test. And this is why Canary is so valuable. Now, Canary is also a function, its usefulness is a function of traffic and time. The more traffic you have, the less time you need to canary something. If I'm Netflix, I can canary something in like 15 minutes, maybe 5 minutes. If I'm Joe's Shrimp Shack, I don't know what the local restaurants are. I don't know anything about Detroit. I'm sorry. I assume there's a Joe's Shrimp Shack. That's what it's called in Detroit. They probably don't get a lot of traffic, and you do a Canary on that, and you might take 3 weeks to get enough traffic to actually have meaningful data. So Canary is specific to cases where you have enough volume that you can actually burn things in and test them in a reasonable way. Now, the ultimate goal, so we kind of talked about this from the angle of limiting blast radius, and that's actually the focus that helps you get to the actual goal, which is for your code delivery to be an assembly line. Now, nobody wants to feel like they're working on an assembly line. Actually, that joke probably doesn't work in Detroit. That's like the wrong venue. They're like, our dads worked on those assembly lines. From a coding perspective, I don't want to feel like I'm working on an assembly line. I don't want to feel like I'm a creative, amazing snowflake creating magic, you know? But from a code delivery standpoint, from the moment that I hit commit and I push that, everything should just be automated, including the deployment. And if I can do that, actually I take all of the junk part of my job, which is dealing with like chasing people around to look at my code review, or telling people that the tests are broken, or sitting with an engineer, release engineer as we do a manual deployment. All that stuff is a huge time suck. The most valuable part of your organization are your engineers. And I think everybody here should be in DevOps, and you should be thinking of yourselves as productivity engineers. I'm here to make my development team as productive as possible. And in order to do that, I have to have an assembly line that takes care of everything going into production. I should be getting to continuous delivery, continuous deployment as my goal, because I've got the system so burned in that I have high confidence and reliability in my automated releases. And canaries are a critical component to build that confidence. So we're going to use Helm for this. Going back to the hand theme, how many people are using Helm today? Okay, so about 25% of the audience raised their hands, which means everyone is using Helm, because that's the maximum number of people that have raised their hands. So Helm is a package manager for Kubernetes. So if you aren't familiar with Helm, it's like NPM, but for Kubernetes, you can say things like, oh, my application requires Mongo, and it will just go and get Mongo and deploy it and do its whole thing. It's also a templating system. Now, Istio is a service mesh technology that we're going to use to enable a canary. Now, if you're not using Istio, can you still do canaries? Absolutely. You totally can. We actually have a built-in, we have open source tooling that allows you to do canaries at codefresh.io/steps. You can go to the Canary Release on Kubernetes. You can use that. But Istio is super flexible because it allows us to do a lot more. Now, the way that Istio works from this very simple diagram is essentially in Kubernetes you have your pod. So you're running your container, and Istio will inject a sidecar into that pod with Envoy on it, and that will enable basically all traffic will go through that sidecar, and it will enforce both security policies, so you can do things like, say, only stuff from service A should be able to talk to service B. You can also enable SSL across all of your services with one click, because the Envoy and Istio will take care of it automatically. But one of the key components is a thing called Mixer. And Mixer allows you to set rules for what pods, what services are going to be exposed in what scenarios. So you can actually canary a pod specifically. You can canary a service specifically. Excuse me. You can canary an entire Helm chart. So now you can actually stand up a whole stack of microservices and canary all of it at once. And you can actually even canary clusters. So you can actually stand up a whole new cluster, canary that, and then shut down the old cluster. So this is something that's possible to do with Istio because of the way that service meshes work and enable that. Now, there's actually a fair amount of stack to get through, right? We have a Istio ingress, which is how people get into the cluster in the first place. We have a gateway, a virtual service, which then will link up to a service, a deployment of pods, blah, 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 blah. So what we're going to do is we have a Helm chart that basically takes the service stack down to the pods and container level and replicates that over here so that we can then canary between these two services. And basically the virtual service is where the canary magic happens. Now, how should this work? Well, I love this quote by David Fincher. He's a filmmaker. He says, "There are a million ways to shoot a scene, but really there are maybe two, and one is wrong." And I feel this way about DevOps all the time. Like, oh, how should we do it? Oh, there's a million ways we can do it. But really, there's like maybe two. One of them's probably wrong. We should do the other one. So how do we marry in Helm? Well, what we're going to do, Helm normally has this release flow, right? So every time we do a deployment, it pings up a new release. And that release becomes essentially a rollback point that we can use in the future. It basically encapsulates all the changes that have happened in that release. And so what we're going to do is we're going to have our regular production release, that's our blue version, prod version. We'll have release 2, which is going to have both versions, and release 3, which has one. Now, you can change and decide what percentage of traffic you want to send into a canary. The more traffic you send, the greater exposure to risk, but the faster the results. So you actually have to decide based on how much traffic you're getting and how mission critical the application is, what percentage of traffic you want to send, and then we'll increment off it. So I'm going to show you a pipeline here. This one, we're going to make a commit. It's going to build the images. It's going to build the Helm chart. It's going to deploy the new version of that Helm chart with both versions. And then we're going to go through Istio to actually increment the percentage of traffic, running health checks each time, and then we're going to complete the update at the end. Sound good? Yeah! Everybody's like, those hot dogs. All right, so demo time. I'm going to be using CodeFresh to run this demo. And the application I'm using is called ColorCoded. It's actually the very first Go app I ever wrote, and it shows off all of my Go skills in full glory. It displays this color on it, and it's pretty rad. Thank you. Yes, that's my talk, ladies and gentlemen. But it has one other very unique feature, and that is that when you click on it, it dies. Amazing. Now, it's perfect for Canary because we can actually introduce faults and then see how the health check is going to work. And what I've done here is I've created, this is an advanced technology called iframes. So I have a pile of iframes to give me a sample of what my application looks like. So this is going to allow us to visualize what's actually going on with the Canary release. Now, one word of caution here. In production, you don't actually want people to be moving between the Canary and the non-Canary versions. You typically want to lock them into a version. And Istio does allow you to do this. You can actually target people for a Canary and say things like, I want session affinity. Once they're in the Canary, they're always in the Canary until it's gone or it's into production. And you can also do things like say, I want the Canary version to only go to people in Russia who meet this profile. You can actually do header inspection and do things like only logged in users, only authenticated users, whatever like that. All right, so I've got my dashboard here. Let's go over and I'm going to open up my builds tab and let's go make a change and then we'll explore what's actually happening here. So I've can everybody see this okay? Should I go bigger? Bigger, okay. So I've got my, whoops. No, don't judge me for using Nano on stage. A bunch of people are like, Emacs, this guy. So I'm going to switch my color to yellow here. It's a pretty critical commit. And we'll push this up. Whoops. Go yellow. All right, so now this is going to push up, and we'll look over here and see that our build kicks off. And we should see, there it goes. So my build just kicked off. We'll go ahead and open up this pipeline. Now, while this is spinning up, basically the way that CodeFresh works, see how smoothly I just stuck that pitch in there? Every single step that you see here in this washed out monitor that makes it look like just a pile of white blobs, every single step that you see here is actually running its own container. And one of the nice things about that is that when you write a container, you can actually reuse it as a function. It's a container-based pipeline. And we have a whole library of these steps you can use. These are all open source at codefresh.io/steps. You can even just go to the home page and you can see beyond example pipelines, you can see all the steps that are available here. And these include things like doing Canary releases. And these, like I said, are open source. They're basically all images that you can take and use however you see fit. And so you can actually see there is a Canary release step right here that you can use. So now the Canary, the release has happened. If we look at this Canary rollout, we can see that I've actually set it to send 35% of traffic at a time to this new version. So if I refresh this, you can see now about 35% of my traffic is showing up as yellow. So I've done my deployment. Now 35% of the traffic is now going to the yellow version. So now here's the vote kicker. Who wants to see it fail and roll back automatically? And how many people want to see it go boring and do nothing? Amazing. Way more people voted for it to fail. So what I'm going to do is I'm going to start clicking on these things like whack-a-mole. And this is going to start killing all of our deployments. And actually, if we look in Kubernetes, for example, here, we can see that one of them errors out. We can see the ages of these things. I'm going to keep on clicking on them. This is going to make them more and more angry. I'm killing more and more of them. Here we can see that they're all starting to error out now. And Kubernetes is trying to recover as quickly as possible. So if I refresh this now, I should be back up essentially to full running. I have one crash loop back off, and those go up exponentially. So eventually this will take longer and longer, and I'll start to get more of a denial of service kind of thing going on. But here the Canary rollout has actually completed it. What it says is that there was an issue that it detected because pods kept on dying. Now you can integrate this with a custom health check, but this is a very basic built-in one. And so it's detected the problem and it's removed it from the network. And so if we go back and refresh this, we're going to get all blue versions now. So we actually detected an issue automatically. We removed it from the network automatically. But if we look in here, you can actually see that it's left. I guess it's a little less clear when you use the watch command. What you can see is that it's actually left all of these different instances running. Now, if I go back and look in my Kubernetes dashboard on CodeFresh, what I'm going to do is I'm going to go pull up the cluster that I'm working on, which actually I can't even remember which cluster. I'm pretty sure it's this one. Which is going to show me the services that are running. So we can see these two services are actually running, and actually both of them are considered healthy right now because all of the deployments and pods are actually executing. So one of the reasons you can actually you can basically do the follow-up deployment to remove these. I actually like to leave them both in because then I can actually go in and look at what's going on, even though it's been removed from the network, and so it's not actually exposing users to something that's broken. And further, if I went back and looked at my Helm release dashboard, and I open up this is my colors application here, I can see that same view of the services, and I can also go into my history and actually see what has changed between these different versions, and I could actually do a rollback and get rid of the second version that's been deployed and failed. So I could actually just deal with this through the UI if I wanted. Now, if I look at my two services here, and I wanted to understand what was going on, so I've seen now that my build failed. It was related to this commit. And if I click on this commit, or this image, this will actually show me what image was deployed. And if I click on the commit SHA, it's going to take me directly into the code change that I made that has caused this to fail. And now I can say, oh, OK, this thing didn't work because of these code changes that were deployed. I got to go figure that out. So now what I'll do is, now that I've learned my horrible mistake that my release engineers are all mad at me because, but not that mad at me because it didn't actually affect very many people, I can actually go in and issue a fix for this. And in this case, my fix is going to be adding a space because, of course, well, you saw that I actually caused the fault by whack-a-moling. Everybody got what just happened, right? Yeah, OK. All right, so I'm gonna commit that. Fix my update to yellow. And we will go ahead and push that. So this will go ahead and kick off my next pipeline. And we're going to be off to the races here. So now this is going to roll out as expected. It's going to increment up. And in the Canary Release steps, so if you actually look at the syntax for how the default Kubernetes release works, you zoom in on this, you can see there's actually a traffic increment option. And so you can say like 35 is 35% of the time, 10 is 10% of the time, 90 is 90% of the time. And if you're not using Istio, one of the tricks here is that with Istio, I can split traffic in any way I choose. But with Kubernetes Plane by itself, I can only divide up traffic based on the number of pods, because it basically just works off a round robin. So if I use this default Kubernetes Canary deployment, what it will basically do is spin up and manipulate the number of pods that there are in order to create the Canary. Now, I can't do session locking. I can't do affinity, right? So once they get into the Canary, I can't keep them in the Canary. They can basically move between. And in many applications, that may not be a big deal. But you do have a path forward if you decide to go with that other method. Now, my build should be just about ready here. You can see my Docker image built in about 19 seconds. That is because I have fantastic caching built into CodeFresh. Ding! So now my Canary rollout is started, and we're going to see the traffic start to flow over. So I think I actually probably should have set a readiness check on this. So that's a pro tip: your readiness checks. So this will continue to roll out and increment. And we could watch that, but that would be kind of boring, so we're going to move on. So if you want to replicate this demo, the pipeline, the code, the application is all at github.com/todaywasawesome. That's my Twitter handle and my life philosophy, /color-coded. And if you'd go to my Twitter account, I'll post a link to this right after. And you can, of course, do your own Canary with our free images at steps.codefresh.io. Just redirects to codefresh.io/steps. And you can actually do this with plain Jane Kubernetes and then go and do it with Istio later if you so choose to see how that goes. And you can really feel the difference. So with that, I have successfully demonstrated our Canary, hopefully. Everybody's excited. I've woken you up from your lunchtime nap, and we have a minute for questions. Cue applause. Thank you so much. Oh my gosh, what an overwhelming response. Thank you.
We actually have about 5 minutes for questions. Any questions there?
This is a talkative audience.
Yeah.
Okay, actually, that's a great question. So if I went and killed all the blue squares, would it then rapidly increase the movement into the new release? The answer is no, because I already went through and validated the blue release when I did my previous Canary run, right? So if there's now a new problem with Canary, this is kind of beyond the default logic of, like, that sounds like probably some other service rollout is maybe causing problems with this service. And that's one of the tricky things about microservices in general is if I launch a new version of my service that causes instability, it could actually be causing instability in other systems. Now that's usually evidence of bad architecture, right? Because it shouldn't, errors should show up where they originate because of the way that microservice architecture should work. But that is a potential danger, especially as people are migrating. So that's a great question. Okay. So if blue and yellow starts dying at the same time, so the way that the health checks work, which I didn't get too deeply into just for the sake of time, is essentially there's a default health check that looks for death, but you can add a secondary custom health check based on whatever metrics. You can have it linked in with Sumo Logic. Who's the logging provider that sponsored the event? Like Dynatrace, maybe?
Datadog is here?
Datadog. Yeah. Super, you could pull it from Datadog. Datadog, for all of your logging needs. So you could pull those custom metrics from Datadog and have that basically mark something as bad. So in essence, it's kind of up to you. In this default configuration, it is only looking at the health of the new version. And so if you're seeing failures across both, well, maybe in some way that's caused by the new version, but that would be new, and it's also skipping over the fact that we already validated it earlier. So we wouldn't expect it to be failing at this point anyway. So but that's a good question.
What are some of the hang-ups you see people have with this first starting?
What are some of the hang-ups I see with people getting into Canary in the very beginning? Oh, Istio specifically. Okay, so Istio, the biggest thing that I see is people get overwhelmed because Istio has so many capabilities. I know when I got my Game Genie cheat code box and I opened that up, I felt very overwhelmed as well. So it's very similar to the adoption curve for Kubernetes, where people look at it and they're like, this looks crazy complicated. But then once you start using it, you're like, oh, okay, I kind of get how this works. I understand it well enough to use it. So I think mostly just being intimidated and overwhelmed with the idea of service mesh in general, because service mesh is sort of a complex idea. But it's actually a prerequisite for a lot of things like Knative, for example. If you wanted to run Knative on top of your platforms, you actually have to have Istio. They do have an alternative provider for a service mesh, but you still have to understand service mesh on some level to take advantage of that. So mostly just getting overwhelmed. There are some tricky things about debugging Istio, just because once you have that many layers in your stack, tracking down where exactly you're having an issue can take a little learning curve to go and like watch the right logs and see what's going on. But in general, the other issue with this actually that we didn't talk about, we're all yellow now. The other issue here that we didn't talk about is idempotency. So the Canary, the way you set up your Canary, you want it to be idempotent. So you want it to be able to roll out even if there's nothing deployed. And you basically want it to be able to just deploy the new version and look for issues. Just in case you just migrate clusters, you don't have to set up a new thing before you run your pipeline. That is one common occurrence that I do see. So that's good to be aware of. Cool. If there are no other questions, I'll be around afterwards. Again, love for you to, you can follow me on Twitter at @TodayWasAwesome. You can actually do all this stuff on CodeFresh for free at codefresh.io. So everyone will judge me a huge success if a bunch of people create CodeFresh accounts from Detroit today. So big appreciation on that. And other than that, thank you very much. Appreciate it.